Hello and welcome to our talk, Building a Cloud-Native Infrastructure as Code Platform for an Enterprise by Leveraging the Kubernetes Ecosystem. Yeah, very long title. My name is Florian Hopfensperger. I work for Allianz Technology. And where are the other Allianz guys here? Give me a sign. Thank you. I'm there, the technical lead for the Infrastructure as Code Platform. And yeah, next to me is my dear friend.
Hi everyone, I'm Yury. I'm Principal Solutions Architect at Upbound, and Upbound is a company we are creators of the Crossplane project. We're excited to be here. And Florian, please kick us off.
Let's go. So it's for me an honor to stay here and talk about the platform, what we have now built almost 4 years ago, and we are still developing all the days. So to give you a little bit of context, I start why we did this. So why we built a platform 4 years ago. So first of all, I want to describe the context because it's maybe not that usual, our setup, but I always compare ourselves with eBay, right? On the one hand, on the left side, you see maybe my mouse pointer, you have a product team which wants to sell their products like eBay. Somebody wants to use the eBay marketplace to sell their products, but these guys are not selling like real products, they are selling infrastructure automation, like how to get an EKS cluster, how to get a database, how to get XYZ. You could imagine what an enterprise company needs, right? And on the other side, you have the application team, which is the actual customer. So the good thing about this platform is only for Allianz employees, so to say, so we don't have any external customers. And on the bottom side, you see like the platform team. This is actually the team where I'm working at. We are maintaining, developing the platform and creating features and want to fulfill the needs of both of our customers. So what we had back in the days was a lot of challenges and a goal. And I just walked through them now very quickly to tell you why we did this, why we built it. So we had, back in the days, Excel sheets to get onboarded. So somebody had to fill out, hey, I want to use a new EKS cluster. Yeah, first you need to get onboarded. You need to request a project somewhere and do it. What we want to do is like self-service onboarding. So everybody can just open some form, fill it out, send it, and it gets all what it needs. So here, therefore, we are currently leveraging ServiceNow. So ServiceNow is a single-time effort for each of our customers. They fill it once out, and then ServiceNow is talking to like a Kubernetes custom resource definition, and this resource definition then makes sure that the customer gets all what it needs. So there's a single-time effort to get a project, and then in this project, they can request different other infrastructure. Second thing was, obviously, when you have product teams which are offering automation, you could imagine that different ordering techniques were used. So, for example, you need to open a GitHub issue, you need to send an email, use Jira, Kanban board, chat some unofficially in team, hey, could you please set up an EKS cluster for me? No. So what we want to offer them is an unified interface to manage the infrastructure. And then what else? What we are leveraged here is in the end crossplane. So all of our product teams are writing crossplane compositions, and the customer in the end has a GitHub repository where the customer places his needs, so the so-called claim, and then Argo sees these things to their dedicated control plane, and then everything magically is happening. Then next thing is, we want to offer marketplace. So it was always hard for customers to find out what infrastructure resources you're actually providing, right? So what we want to offer is a central marketplace where they have some kind of a catalog where they can search, okay, I have possibility to get an Azure subscription, an AWS account, a cloud database on Azure, I don't know. You could imagine, right? Therefore, again, cross-plane, GitHub, and some GitHub actions to publish this marketplace automatically, that they always see what is available for them. We had, obviously, you could imagine when you're a product team and providing a service, you need somehow access to their subscription, right? And when you think about this, these product teams need some permissions. So we had problems with security and teams with admin privileges. Where we moved into is basically we're leveraging dedicated control planes. So each customer has their own dedicated control plane, and then we use on top of that Kyverno to do proper security, additional security with policies or fulfilling internal enterprise guidelines. Again, fulfilling internal enterprise guidelines, you could imagine you cannot only request an Entra ID security group, right? You maybe have already a team sitting in your corporation which offers an interface for that, right? So therefore, to also fulfill their needs and all the attestation processes and similar, we are talking to their API. How we do it? We just write custom cross-plane providers which are then talking to their API, to their already provided API. And then that nobody is blind, so that you know what you are doing, is like we are collecting metrics and provide dashboards for our product teams that they know, okay, what is happening. Therefore, we are leveraging Grafana, OTel to collect it and write custom metrics with KubeState metrics. Yeah. Moving to the next slide. So what does the overall architecture look like? And this is a very simplified diagram, because this diagram alone and all the technical components which are involved would be a single talk, 2 talks, I don't know, I can talk a lot of this. And here you see we again have the 3 personas. We have the product team, the platform team, and the app team. Let's focus quickly on the app team. As I mentioned, they're using ServiceNow to get onboarded. ServiceNow talks then to a Kubernetes cluster where Crossplane is running. Then this Crossplane sets up a dedicated control plane, right? Dedicated control plane. You see here the differentiation between a hub and a spoke cluster. We have that many customers that we cannot use a single Kubernetes cluster. So we have multiple Kubernetes clusters where we have then like a control plane on top of that, and then this is basically the customer entry. When the customer now want to, let's say, request an EKS database, he puts this in GitHub, then this central Argo CD, which is used by customers only, makes sure to sync it to the right control plane, and then the Kubernetes and cross-plane magic is happening, and it's then creating AWS resources, Azure resources, internal resources, whatever you can think about. And then what is also important to understand here on this diagram is like there is a split, right? There's a split between platform management and the actual runtime cluster. This is best practice to do so, that if something breaks, you still can manage it. And like the platform team and the product teams are talking in the end to this Argo CD management cluster, where they can then define which product is deployed where in production, in integration environment, wherever, right? And then we have obviously some CI automation like Prow or GitHub Actions. Next slide is now in the point of view of the customer, what the customer actually needs to do. So the customer has in the end a very simple process. First of all, he selects a product, what he needs. I don't know what he needs. Hopefully the customer knows what he needs. But then he's filling out this claim, putting all the parameters you could imagine. I don't know, when you need a new Azure subscription, there may be some, what environment it should look like. Should it be dev, test, staging, or something like that? Then they create the PR. So we are following a purely GitOps way of doing it. We want that this guy is creating a PR, because then we put on top of this additional automation, like automated validation if this YAML file fulfills all the schemas, if it can be validated, and we also on top of that provide some deletion protection. Funny story about deletion protection. What happens when you change the metadata.name of an YAML file from Kubernetes resource? When you use Argo CD, it's get deleted and get recreated. Think about this in an infrastructure world, deleting an EKS cluster, creating a new one. This is a nightmare, right? So we want to offer here additional protection. Then it gets this PR moved by a force ice principle approval. Argo CD syncs the claim, Crossplane fulfills the claim, right? And then the customer has now the possibility to check all their claims in Argo CD or connect directly to the control plane and look at their status. Now they have monitoring capabilities of the infrastructure already out of the box. So this is what I mentioned before. On the left side, you see like, this is obviously, I removed a lot of information just to give you a heads up how it could look like. It's like on the left side, you see like the Git repository where they simply can select a claim. Then here, this little website where they can search for claims. And here, I just wanted to visualize how easy a subscription could look like, that they get their own dedicated Azure subscription. Then what we achieved now, we have now declarative infrastructure setup, right? We have 4SIs principle with pull requests. We have deletion protection. We have a single point of entry, no longer different ordering technologies, single point of entry. We have a well-defined API by custom resource definitions, and actually customer could theoretically have their own automation, which is integrating with this, right? And then we have monitoring capabilities, yeah? So now how it looks like when a product team develops it, right? So similar stuff. We have here, it defines first of all the example, so how it should look like. In the end, what is the API for the customer? It's this very important step. Don't underestimate the time for this. This is very, very important. Take much time on this. Then they declare the XRD, so to say. Then they define the tests. Yury will quickly do after this a test a demo, how it looks like when you have a test-driven development case. So defining tests, defining the business logic, run the tests, and repeat the cycle as soon as it fulfills your needs. Create the PR, sorry for that, create the PR, then some automation builds automatically the package, and then they can do like canary releases. They can then test their product, what they just developed, in let's say 1, 2, 3 control planes. I don't want to touch already at that point 1,000 different control planes. Maybe I just want to try that 3 control planes if it's really working. And this is what we're doing here with test in real world. Then the PR again gets merged. GitHub Action is publishing the somewhere, and then they use later on when they deploy it at Grafana to monitor where what is installed and so on. So just to give you like an idea how canary releases could look like. So you have like a control plane add-on, you select some customers, 1, 2, maybe 2 pilot customers, and then you say, okay, I want to deploy their version 2.4 with important bug fix. Just to test it out, and then later on, I can release this to everybody. Okay, time for demo. Let's pray for the demo god.
All right, thanks a lot, Florian, and thanks a lot for the great slides. The amount of cross-plane popsicles logo on the slides is nicely overwhelming. I like it. So let's switch to CLI. Hopefully it's visible. So what we are going to work with is a simple Azure network abstraction. As an example, imagine we are in a team, in Azure team that is building and network abstraction to drive some Azure network fabric. So we start with example. As Florian mentioned, everything starts with example, and that's where we can follow the shape of the API, right? So we can just create some draft and agree as a team what our API will look like. So at this moment, it's just a draft and nothing implements it. Then we have a thing called definition. If you're familiar with cross-plane, you know that with an XRD composite resource definition, we can actually extend the Kubernetes API with the custom fields and create this custom abstraction. And while we're on XRD topic, can we please make a quick show of hands who already built something with cross-plane before? Maybe just. That's pretty good. Thank you. Yeah.
Keep on going.
Yeah. So at the time when we applied the XRD definition, nothing still implements it, right? So to actually create some logic, we need to implement the composition, right? And here we will operate with a simple patch and transform function, a cross-plane function. Please don't take it as official recommendation. We kind of in Upbound, we are on a way to deprecate original function patch and transform stuff, but it's still lightweight and nice to demo. And we still have quite amount of organization who are still using patch and transform in production. Is that right, Florian?
No.
So, pretty simple composition. It instantiates a set of resources like resource group, a virtual network, and a subnet, right? Nothing special, actually. So what we are going to actually tackle in this demo, so how we can validate, ideally in offline mode without end-to-end testing during our development experience, how we can be assured that our cross-plane composition does the correct stuff. So first thing first, we are going to do a really popular way of cross-plane render. So cross-plane render is going to take the composite resource composition and function YAML as an input, and we can run it, pipe it to a queue for a nice view, and we can already see the desired YAML stream. So we can already manually evaluate what our composition is going to produce with these specific composite resources. So we already can see that it's going to be resource group, subnet, virtual network with specific set of parameters. So it looks like a correct, we are on the right path, right? But we still do not have any validation that the spec is correct, that it's going to work in a real scenario. So how we can enhance that situation? So we also have a cross-plane validate command that can automatically verify the desired state, the YAML, rendered YAML of your composition, your custom resource. So what we are going to do is just make the same render, include the full XR, and pipe it to the validate. So we're just running this validate demo for convenience. And here we can see that it was partially failing. So what is happening there? Validation command is actually managed to catch something for us. So we have a bug in our composition. There is some unknown field location. So most probably we did some typo. And let's look at the implementation code, right? Yeah, there is spec for provider location, so most probably it is just a plural typo that happens all the time. We can validate it again, and now we have a validation state green. So everything is offline, you didn't have to deploy anything. And as you can imagine, you can use it locally and use CI/CD pipelines anywhere you like. All right, so there is you already can see a pattern, right? So we have a render YAML stream, and we can create some interesting things with it. So what I prepared for this demo is a simple KCL-based test suite. By the way, who is familiar with KCL configuration language? Who used it before? Okay, definitely less amount of hands, but it's great that it's getting there. So KCL-based test suite, it basically can grab the resource, desired composed resource state YAML, that is produced by render, and evaluate it, and this way we can actually check the interesting parts of our composition logic. So we can check, for example, our location, right? So we can double check through our examples that the test is actually working, so we can create non-existent region, save it, make render test. We're just encapsulating these commands with a make file, and here we go. It managed to catch that location is not matching. So we can create these kind of expectations, and this way we also validated that our logic is propagating the desired region to underlying virtual network. So it's useful stuff. Now we can run the render KCL test suite again, and here we have a green state, right? So we have a naturally growing regression test suite that is currently green. Imagine that we want to add the new feature, and we are going to use a nice approach of test-driven development. So test-driven development, who is familiar with TDD? Yeah, so a lot of hands, very nice, very good practice for generic software engineering. So this way, we apply in TDD, test-driven development for infrastructure. So we are writing the failing test first, and our test is going to assert that our subnet is going to have a Microsoft storage endpoint. We run the test. We expect, obviously, that it's going to fail because we don't have yet implementation for it. Implementation is going to be super simple and quick. I have it's almost ready in a composition code. So we're just extending service endpoints, and this will be our implementation code, nothing special. So we are satisfying our failing test with the actual function implementation, and this way we are making the test green. We're running the test suite again, and now everything is properly passing. So we achieve this TDD flow for infrastructure. So it's this test-driven development, red, green, and potential refactor flow from standard software engineering, and now we can apply this to infrastructure. It's pretty much very advanced situation to be in. And at this stage, you already can evolve your custom composition, custom abstraction creation in a fully offline mode to the very good confidence level. At the very end, you obviously need to run some end-to-end tests, and we have an uptest framework that also automate this for you. It will deploy the local cluster, install crossplanes there, install provider dependencies, wait for configuration, install provider config, and we'll apply composite resource and we'll wait for a composed resource to be ready on the cloud provider side, and if everything is successful, it will tear it down. This test is obviously the most costly one, and you will use it only on the tip of the test pyramid. If you're familiar with test pyramid, this is like this layer that is most costly for you and takes the most amount of time, and you use it carefully. So for 80% offline composition tests are more than enough to drive successful creation and get the super fast feedback loop from the system. So this concludes the demo, and this is a set of recommendations and tooling and approaches that you can use to drive your cross-plane implementations and make it fast and reliable. Thank you.
Demo gods, where is us?
Yeah.
Nice. So, going back to the presentation. Wow, looks good. So, demo. Now, Yury developed this cool Azure product, right? Let's imagine that he already published this somewhere, right? We followed everything, and now he wants to actually monitor it. How it's used by customers, where this configuration package is deployed, and stuff like this. Let's imagine that one. So we have some monitoring requirements from our product teams. So as they are also customers from us, we want to make sure to also fulfill their needs. So maybe configuration package, the healthiness of this. Providers, if they write custom providers to fill some Allianz guidelines or internal guidelines. Functions, if they develop some custom functions, they also want to see if they're healthy, if they're correctly working, if they're in crash loop back off, I don't know, something like that. Then they want to see maybe what claims are used. So what is my most demanded infrastructure resource? Is it an EKS cluster, RKS cluster, or is it like a cloud database? Or is it Jenkins service? I don't know. Something. They want to have some dashboarding where they have some metrics. And then, last but not least, they theoretically can also directly connect into the control planes, and in case of an issue, then debug the composition and the claims directly in the control plane. So how we did it, so in the end, we are again leveraging kube-state metrics to provide some custom metrics about configuration packages, providers, all this stuff about also the claims. Then we are collecting this with OpenTelemetry and then saving it into a central Mimia storage and then creating some Grafana dashboards on top of this. And besides that, the product team can also use Argo CD to have a first glance or first look at this, how the actual claims looks like. Yeah. So here I just brought two simple dashboards with me. One, this is like the monitoring of a configuration package. Here, for example, we have the cloud database configuration package. We see there are more than 1,000 control planes are installed with that, and we see like how many are healthy. 114. Maybe it's a good idea for the cloud database team to check why they are not healthy. Huh? So, but this way you give some insights in what you're actually deploying and operating all the time. And here, for example, a claim. Here is like monitoring the claims. Here you see all of our claims which are used, and more than 10,000 claims already out in our system. And you see, like, not sure if it's readable, but here is a GitHub enterprise organization, an AWS dedicated account, or a dedicated VPC, right? More than 10,000, you see the healthiness. And here you can also like have a very good metric about deleted resources. So at the moment, we have 118 claims which are in deletion process. So most probably we should check them, why they are still in deletion process and why the cloud infrastructure is not already deleted, or maybe it's deleted, but the business logic just not do it correctly, right? Last but not least, just some future directions where we're heading into and some lessons learned. Obviously, just a handful of lessons learned. But what we see very, very beneficial is maybe an AI, so some AI to select or helping their customers to automatically select the right claims and filling out this claim. To make it easier, even more easier than it already is for them to have something like that. Then you can think about billing, as we are a corporate enterprise. You could think about different cost centers. So if my customer is using this, maybe this product team which is offering the service want to charge them, so they can in the end use like the central point of metrics to also do then charging based on this. And then lessons learned. Very important, I want to repeat it again, develop a platform or an API for your customer needs. It doesn't bring you any benefit when you use the coolest technology which is available, which is unusable for your customers. Think about what the customer actually wants. For example, thinking about a database. Does the customer want to stop and start the database with the claim, or maybe does he directly want to go into Azure and click a button, stop, right? Think about this, because then you spend too many effort on something which is not used or not very user-friendly, so to say. Then Kyverno and webhooks can slow down. We had, I would say 2 years ago, an issue with Kyverno. They are created an infinite number of update requests, and this basically caused our control plane just to stop. So make sure that you really only use it when you don't have any other option, right? YAML. This is also the reason why I put here like this meme here. As you could imagine, we're a corporate enterprise with a lot of different users. So back in the days, there maybe were Java developers which configured some Tomcat services XML, right? And now they should play with YAML. So help them to make it easily possible for them to create these claims easier. Do some validation. Help them with IDEs. Make their journey easier. Monitoring is always forgotten, in my opinion. Implement it on day 0. You need, when you want to deploy today a product, you need to have already monitoring in place. Because otherwise, when you have more than 1,000 clusters or control planes, it might be impossible for you to do proper monitoring afterwards, right? Think about this. And then, last point for me at least, is establish feedback loops. Get feedback from your product teams, which are using your platform to offer their products, and from your customers. Because you're not building the platform for yourself, you're building it for these guys and for the other guys. That's it. Thank you very much. We are now open for questions.
Yeah, we have time for questions.
Yeah, yes, you have first row? Sure. Yeah, I can hear you. I will repeat the question, or Yury.
Yeah, so essentially, this is a very good use case for disaster recovery when you want to keep things rolling when disaster hits. But there is a flaw which we feel can be bridged. Can you think of a way wherein, when you do these deployments, I did see you have used some subnets, and you also had configurations because you're using Azure. Yeah. You have to also look for the private DNSs. So when you switch, there is always a problem there because it's not seamless. Because those DNSs, when you switch, you have to make sure that the DNS doesn't change when you move from environment to environment, because the DNS will remain one. You cannot change the DNS. When there are 2 DNSs, it's fine. You can just switch to the new DNS. But when the umbrella is one and the internal wiring has to be changed, then there is a problem. There could be downtime. How would you address that?
So it's about like keeping the external identifier, if I understood the problem correctly. So basically on another, so I'm assuming you instantiated this fqdn.example.com on a control plane 1. On a control plane 2, you want to either read from it or take over the control. You need to import it, right? So there is a special crossplane IO external name annotation. And if you match the identifier, and then in Azure they are nicely predictable for 95% of the API, you're matching it, and you're telling crossplane, please import and take over the control for me for this specific crossplane instance.
So
and
you're
it will
saying
work.
the internal DNSs will be different, but the external, it will present the same thing?
Yeah, but the identifier will still be unique. So yeah, so you need to match this identifier, so it's specific to the specific managed resource, and you also have a management policies. So on a control plane 2 or 3 or X, you can actually make a observe policy only and just read from it and not take over the full read-write control. So it's definitely
Would you make
possible.
this a recommendation on disaster recoveries when there are 2 regions?
Yeah.
When you want to switch, this could be a way to have green all the time?
You can put it like in a standby mode for sure, yeah. And flip the management observe policies when you need to read write on another one and read only on the first one for sure.
So, thank you.
Yeah, thank you for the question.
Yeah.
Oh, next question here. Yeah.
Yeah, it's a bit tricky, like saying up, like, do we need to really get this much complicated? As I mean to say that this is a cross plane, and as well as we have Pulmi, we have Terraform, we have Tofu, and we have every cloud provider have tons of things in. Even though that, like, even I have seen that cross plane even get delayed SDKs as compared to the cloud providers, as they will get eventually like the latest providers and their APIs, I mean to say resource managers are like what you can say, call it their SDKs. And even often like Terraform Enterprise gets it along with their like a Pulmi gets in. While we are going with the, as you said, cross plane, and we should be even going with the CRDs, that's the one of the complex thing. We can see it in the Kubernetes. I'm pretty sure everyone agree with this point. Like, as you know, like if you're extending the functionality later, later in the journey, it's very hard to define your APIs, and it has to be like, let's take example as you have developed everything, as you have experience with the CRDs. If someone joined as a platform team, and he has to adapt, and however he has the knowledge of Kubernetes, it's very hard for him to, or like it's pretty new for him to adopt you, and making the pace for him at least takes 3 months for sure. I'm pretty sure on that. Like, how can we make this as simpler to embed someone who comes out from outside?
I mean, like, first of all, they need a fundamental understanding how Kubernetes and the controller concept is working, right? What is a custom resource definition? On top of that, then best of this, you can think about getting used to cross-plane, understanding how functions in the end are working, right? And then, but this is not different than when you think about like Terraform. How many difficult Terraform modules you have already seen in the past, right? Where you see a lot of like encapsulation with Terraform modules. I guess we're fearing here the same pain. But the good thing about this approach is like, it is not magic, right? It is all readable. It is code. It is test-driven, so we can easily adapt. Yeah, I totally agree with you. Yeah, you need some adaptation, but I'm not sure if you can tomorrow select a new developer and he is already fluent in writing everything out of the box. They need some training. They need some get their hands dirty. So if you want to get started with crossplane, just get your hands dirty. It doesn't help you when you just read theoretically things.
Yeah, in like, as one more thing apart from this, like the same provider, like even like if you take the cloud provider.
Yeah, still.
Okay. If you take the cloud provider as Azure, as we have seen in the example, Azure offers one of the functionality as Azure Lighthouse. Azure Lighthouse, yes. With the same, you can achieve similar things in, right?
In Azure?
Yep.
But only in Azure, right?
Yeah, it's same.
But when I have AWS?
No, it has the same, different provider name in.
Yeah.
Yeah, for GCP it has in. Even IBM Cloud has it. Just
on Azure Lighthouse?
Yeah, Azure Lighthouse.
Okay, I don't know about this. Yury, maybe you know.
It handles everything in RBAC, and you can have like complete access to the customer, whatever the access you need, and you can even propagate your RBACs in.
But is it a control plane? Does it have a reconciliation loop? Does it automatically mitigate the drift?
Yeah, it's all about us. Like
Is
we-
it,
we are-
is it
where
like
we
a,
are putting up our templates.
yeah,
in
but
place.
is it operating on top of a Kubernetes API? Yeah, so like Kubernetes API in associated integration is a strong point of crossplane, right? Because you're extending the standard Kubernetes API and you inherit all the Kubernetes best practices.
Yeah, I
So,
agree.
Yeah.
Basically,
And when I don't have Azure, I don't have Azure
Yeah.
Lighthouse, but Crossplane I can just install on my laptop.
yeah, I agree. Like while we're coming with the different things in, it's very hard to manage. That's what my thought of.
Well, it's about development experience as well. So we are heavily trying to simplify it, right? So with new functions with, that are more close to standard development experience, test-driven development, and basically we are closer to operating APIs. And APIs nowadays, we have actually a great case of engineer from your company who has a just Python developer background, no infrastructure, and he was onboarded on Crossplane super fast manner.
Yes.
Because just API knowledge is enough to deal
Because
with
we're just
Crossplane.
talking
Yeah.
about REST APIs.
Yeah.
If you understand at some point REST
Exactly.
APIs,
Yeah.
you get to use to Kubernetes, you get to know to everything else.
Hi, greetings from Lalit.
Hello?
Yeah, so super excited and thank you for informative session. I'm handling a platform engineering team for my company. So I would like to know how you have handled the monitoring stack setup, particularly like when you are spinning up multiple client environments, right? So how, like, do you have any singular setup for it? Or it is a per client, it is a dynamic provisioning, Grafana, particularly Prometheus?
Now I get your point. So we have a central Mimir. So per environment, we have a Mimir instance, which is acting as metric storage, so to say. And then we have a Grafana OTel agent, where we are connecting then to all this kube state metric endpoints, so to say, scraping all the metrics, have some transformation, build with OTel, and then pushing them to Mimir.
Per tenant, right? Or per client environment, the setup takes place. Or it
We
is
have
a singular.
we have labels. We are distinct. So we have it per environment, Mimir per environment, so to say. And then we have additional labels where we can identify, does it belong to this tenant, does it belong to this tenant.
Got it.
So you can
Got
just...
it. Got it. Yeah. Thank you.
Hey, hi, this is Vijay. Thank you, it was a great presentation. We have similar framework in our organization where we use Kubeli instead of Crossplane. But what drawback we have seen when we testing Crossplane is when we create a composition, when a customer comes to explain the claims, we see a lot of other specs, which is a default spec of Crossplane, which will be listed. So that will be like a over information for the customer or a developer. So that is one drawback which we have seen when we tried using Crossplane.
So you're talking about this in the claim that there's some cross-plane related informations are visible, right?
Exactly.
With cross-plane version 2, it becomes a little bit better. There is like a substructure cross-plane, and then there are only the cross-plane attributes that are described. But this is already better with cross-plane version 2?
Yeah, it's better, and you also have a control over what you want to propagate from underlying implementation to the claim status. So you have a status transformer. It is available as a separate function and also as part of function go-template and function KCL. So you actually can have can create dynamically these user-friendly messages instead of exposed to the to all the cognitive load. Yeah.
When you really want to hide certain API for a customer, then it's a little bit difficult. Then you need to think about another aggregation layer. For example, using KCP that is then connecting to a CRD, and then you have really a very minimal abstraction. But it could be very complicated.
Yeah, it's lightweight abstraction, but you don't want abstraction leak at the same time, right? So you need to find a balance here.
This is the difficult decision, but this is the API, what I mentioned before, right? Designing the API for the customer is the most important thing.
Sure, thank you.
Thank you for the question. Any other question? Here? Okay.
Yeah, I was wondering how you manage, if you have any common abstractions that you use, for example, like standard VPC or something like this.
Standard what, sorry?
For example, if you have like a standard VPC and you have many product teams that want to utilize it, do you use do you stack up the managed resource like XRCs on top of each other, or you?
So when
do
you
something else?
I can think about one example, maybe Yury also, but I just can think about one example. We have a team which is responsible for Kubernetes automation, right? And we have a different team which is responsible for like AWS Azure accounts, okay?
Yeah.
So they are providing then the possibility API-wise to create a new AWS account and to create the VPC. So now when the Kubernetes guys, so the product team for Kubernetes want to leverage it, they should look at how they define the API and read out the information from their composite resources. It's basically the contract, what you have between these two product teams. So they are defining some VPC ID, maybe you're interested in, and then they can leverage this in their composition if they are importing this as an extra resource.
Yeah,
Does
okay.
Answer your question?
I think yes, and then I have a follow-up question. For example, like the Azure team pops up a new version of this VPC resource, right? And it's already deployed in production. How do you manage like to deploy like the new version of the Kubernetes that utilizes the VPC?
So you mean the case when VPC is already pre-deployed or deployed by other team?
VPC is deployed and used by another XRC.
Yeah, by some cross-plane abstractions that networking. So there is a way to import resources with this custom annotation external name, but you can import in observe only and get the data.
I mean the VPC is already deployed as an XRC, but
But as a cross-plane, as a Kubernetes resource, right?
Yeah.
Okay.
And it was already used in Kubernetes XRC.
Okay. Okay.
For example, then the API of there is a breaking change for the VPC. How do you update like the XRC of Kubernetes that uses this VPC?
Are you thinking about that they do a crazy schema change, right? So they are moving maybe the VPC into a substruct, and then they get lost of this information, right?
Yeah.
Good question. There are a couple of Kubernetes talks, right, which are focusing on how you do proper Kubernetes API versioning, because breaking changes in Kubernetes API you don't want at all. This is short, in a nutshell, you don't want breaking changes. Otherwise, you need to have some conversion webhooks that you somehow restore how it should look like for this other product which is consuming this, right? The good thing about like when you're just a single company, then you can communicate with each other, hey guys, we want to do this breaking change, please for a period support both. But yeah.
Right.
Yeah, we have a blog post on our Upbound.io by our senior principal engineer, Nick, who is one of the creators of Crossplane. So the idea here is actually to design for evolution. So be ready for design XRD this way that is ready for extension. So classic example would be instead of value string, if you someday somewhere can imagine that it will evolve to multiple elements, make a single element array. It's a small price to pay for extension, right? So this way you can avoid any form of complex migrations. You can just extend the array values, and you don't need any webhooks, right? So
and implement something that somebody gets an electric shock when he tries to use a Boolean.
Right.
Thank you. Great question.
Hi, Rishabh here from FICO. So I work as an automation cloud engineer, and I'm also working on something similar like that. So the issue I mainly face is with respect to whenever a team sends a request and they have sent us some data. So the issue that comes up with the testing. So I saw that you have some validation and scripting, right? So how do you handle it dynamically? For example, let's say I can write a test case where I can say, okay, if you are sending something and if it's in a sub-array mode, okay, 1, 2, 3, 4. Okay, and now I don't know what value you will be passing, right? So how do you handle it? Like, because you don't know if your developer is going to give something which you don't have in your test case. For example, let's say there is a IP address, you have hard-coded it. But the request that I'm getting, I don't know which IP I will be getting it. So how are you managing that thing?
So you mean like to handle with a test suite some dynamic variables, something like that?
I mean, dynamic, so like I saw there you did a VI and I saw the code, and you were like doing equals to and some hard code IP. just to validate if the client YML, whatever they have sent, is matching the test cases, right? So I believe that developer or the customer will not be sending the test cases to us, right? We are the one who are writing or validating if the request that comes from ServiceNow is validated, right? And the data is everything's right. What if he gives some rogue IP, 0.00 open address? So how are we like managing it?
So keep ServiceNow out of the picture. ServiceNow is just to get this control plane. Afterwards, it's not used anymore. So you're thinking about when somebody is pushing like this claim into GitHub, and you are not can 100% have your business logic based on this IP address. Do you have an answer for this?
Yeah, so like in demo test case, we didn't validate that the region was West Europe. It wasn't, well, effectively we did, but it wasn't the main goal. We validated that the value from a composite resource, the specific field value, was propagated to the underlying compose managed resource to this desired location. So that's what we validated. So it just, you know, we validated the flow. The actual value is secondary, just like a test fixture.
And you can theoretically also dynamically look up the value which this is providing. So for example, when this guy is using West Europe, you expect that West Europe should be, but when he is using, I don't know the Azure resources, the networks, how it's called, regions in Azure, I don't have
locations,
no clue. No, I mean like, what are a different name to
regions?
Regions, but a different region name, I have no clue about Azure.
West Europe, North Europe.
North Europe, when they now put North Europe into the claim, then you expect North Europe to flip out here in your rendered output, right?
I mean, so after the manifestation is getting created, right? So the question that we got asked is that, okay, manifestation is getting created, now it is going to be deployed and automated, right? There is no one sitting in between to check if the manifestation that has been created is correct, right? So how are we like because it's infrastructure changes, right?
Yeah, there is additional mechanism that we didn't demonstrate because we had a limited amount of time. So there is a observed resources notion in a composition function, right? So something that a composition controller watches in a context of the specific composition function. So you can actually mock these observed resources, and if you have a part of the logic, for example, look at the, I don't know, EKS cluster runtime ID and get the runtime data, and you're testing for that, it is possible to mock it out in a render invocation, and this way validate this very dynamic logic too. So it is possible as well. So you can just mock out the behavior of kind of external system with observed resources mock, and this way validating the logic in isolated test too. So it is possible.
Basically fetch what you have already there, and then do your testing based on this, if it really works already for these cases. And then you can, I mean, you can write unlimited tests, right? To test everything. But this is always like in software engineering, test coverage.
Yeah, that answers my question.
Yeah,
thank you.
Perfect.
Thank you. Great question.
Do we still have time for question? No, we stop.
Yeah. All right. Catch us up in the conference. Thank you so much. Great question. Really appreciate it. Thank you.